Hi, and welcome to USM Orgo. This is Chapter 5, Stereochemistry. So the idea of chirality and stereochemistry is very important in everyday life, from the gloves that we put on our hands to the enzymes in our bodies. So at first glance it might seem simple or insignificant, but as we go through this chapter, you'll hopefully see how important it really is. So some quick examples. The scent that you smell from a lemon is the S-limonene, and we'll talk about the naming convention. And the scent that we smell from oranges is the R-limonene. Same number of atoms, same connections, just a little bit different around the one carbon, which is this one here. You'll notice that again in carvone, one isomer of carvone smells like caraway seeds and the other one smells like spearmint. So again, just around that one carbon we have a difference in the arrangement of the atoms, and that makes all the difference. So it's something to take a look at when you're doing your reading. In the 60s, thalidomide was given to pregnant women to reduce the effects of morning sickness. So as you're doing your reading, take a look at how the chirality played a role in its effectiveness and why we don't use it today. It's pretty interesting for just having one simple difference about one carbon. So this is a chart at the back of your book, and I'll refer to it because it kind of covers everything in one slide. The most important thing is we're talking about isomers, which you can see at the top. And there are many different types of isomers, which you can see here. You have constitutional isomers and stereoisomers. So if we talk about constitutional isomers, those are ones that have the same molecular formula, but they're just arranged differently. So in this case, butane, you have the straight butane, but then you have a 4-carbon chain now on this side that has a different arrangement around, but you still have the same number of carbon, the same number of hydrogens. Likewise with the other examples there. Now when we talk about stereochemistry, we're talking about the same connectivity but different orientation of groups in space. So that's what we're talking about, like with thalidomide, this carbon around there. So the order in which they're arranged around that carbon are different in those two isomers. So when you talk about stereoisomers, you can have enantiomers and diastereomers. So enantiomers are non-superposable mirror images. We'll talk about a little bit more. But diastereomers are anything that's not a non-superposable mirror image. And both of them are usually considered chiral molecules. And so the chirality tests on page 201, so you can take a look at that and you can use those rules to determine whether a molecule has a chirality center or not. And then also we have a section on page 203 about naming enantiomers. So that goes back to what I referred to before, that R and S configurations around the two different isomers. So take a look at 203 to learn how to name different isomers. And then as you can see, as you go through the chapter, a lot of definitions, but understand these different concepts like racemic mixtures and the different traits and characteristics that they talk about with the different isomers. And then we also have this category of achiral molecules and then things such as meso compounds. So you can take a look at those as you go through your reading, focus on understanding what those different definitions are and how you can be applied in the stereochemistry. Other sections in the book that are important is this idea of optical activity, and that leads to this idea of racemic mixtures. So there's a nice section in the book about that. And then there's a small section on chiral synthesis and drugs. So nowadays you can't just synthesize a molecule without proving its stereochemistry before it can be introduced into our system as a drug. Molecules with more than one chiral center, so there's how to draw them on page 218, this idea of meso compounds, and then also another way to present them, such as Fischer projection, which is on page 223. Then once we know that we have chiral molecules, we have to figure out how to separate those when you do a chemical reaction, and then you have compounds with chirality centers other than carbon, and molecules without chiral centers that are also chiral. So that's it for Chapter 5. A lot of definitions, a lot of things to learn, pay attention to as you go through your reading. But this chart kind of summarized most of the key points. And can't wait to see you in class. Have a good day.